Survey sir has arranged an expert session for all of us, and we know that we have an expert for the topic deadlocks in OS. And so, ladies and gentlemen, please welcome Amruta Khote, an accomplished application developer at Fujitsu India, Pune. Amruta ma'am brings her with her a wealth of expert experience in technologies such as C++, Java, Spring, MVC, and lot more technologies. She is currently pursuing MTech in the text mining and deep learning at she is currently pursuing PhD in text mining and deep learning at VTU Belagaum. She holds a master's degree and a master's in technology from WC Sangli from CSE field, and she has completed her BTech from IT sector from our college only. Amruta ma'am has conducted various workshops and courses and worked extensively in the areas like Java, Spring, PGSQL, GitLab, AWS, operating systems, web technology, and agile technology. Her commitment towards the continuous learning is evident from her continuous participation in the various fields and workshops and FDPs. There is a lot more to introduce about her, but if we would continue to introduce her, it will definitely take the entire session because she has immense type of knowledge. This was the brief introduction of her to make you all know that how knowledgeable she is and what level of expertise she holds in her field. So ma'am, first of all I would like to thank Suve sir so that he has arranged such an expert for our session, and I would like to thank ma'am also that she has taken time from her busy schedule to make us get the knowledge of OS and deadlocks. So further I would like to say that please ma'am continue the session and help us through the topic.
Okay, so good morning one and all. I hope I am audible to everyone. I hope I am audible to one and all. So we're going to discuss the things about the deadlock. So before starting, I guess you learned with something with the operating system. So just a quick, may I get to know what you have learned from as of now in operating system. So basically what do you mean by operating system? Being a software engineer, being what you think, what is the operating system? You have an idea? Which thing will call it as operating system? Okay, no issue. What is the basic things of the operating system? You people are using operating system day by day in life. So the operating system has a very two basic units. One is a process and another one is a resource. What do you mean by process? The things which are running. Currently we are running with this some PPT. Okay, PPT is a program that we install. When we run it, when we open it, it occupies some of the memory from your primary memory from your RAM. So it will go into the running state. We call it as a process. The program will get converted into the process from passive state to the active state. During its execution, it may require to have more and more resources. Resources could be a file, resources could be any space, anything. So the operating system is a collection of different processes and the different resources. And in this particular module, in this particular topic, what we are going to discuss, how we should manage the process and the resources. So let's say this particular classroom is the operating system. You guys are the processes. Let's say there are 120 processes. So what does it mean? I should have minimum 120 resources like this one, what we call bench. What will happen if there are only 20 benches in a class? There has to be some disturbance. I may need to relieve some student out of the class, or I should extend my set of the benches from 20 to 40, from maybe 40 to 60. So I have to manage the number of resources and the number of processes, that combination. The processes demands the resources, and being the head of that family, being the operating system, we have to manage that particular coordination. If this particular process demands, no, I don't want the bench, I want a sofa to occupy. Should I allow? Though it seems very nice, I can't allow, because in a college campus we have only benches. Baba, you can allow to demand 1 or 2 bench, 3 bench, 4 bench, up to 20 bench. But you can't allow to have the sofa, the bed, because it is my out of scope. So in this particular module, we are going to see how the operating system maintains the coordination between the processes and the resources. If the process demands the resources out of its box, number of resources more than available, how the operating system should take care. If any particular process demand, I want in this particular class is a 1000 benches. Do I allow to enter that process? No. That may hurdle me. That may hurdle this particular classroom. Because this particular classroom could occupy only 120 benches, maybe 60 benches. So I could allow only those amount of the benches. So if any process demands more than its capacity, what the operating system should do? If there are 5 processes and they demand 4 resources or the 4 benches, how do I allocate them? How do I given the portion of those benches? So everything, all those management who is doing the operating system. That's why we call operating system is a heart of that whole computer system, intelligence of that whole computer system, brain of the computer system, governance of the computer system. Please. Okay. Now, if something happens, if by taking all such cares, even if something happened bad, if something happened, that management won't be go good one. Now what will happen? There may be a disturbance into the operating system, and that disturbance is called as a deadlock. Obviously, the name something suggests. Do you give it something positive one or negative one? Obviously, it's a negative one. And when it could, this particular situation would occur, this particular, if your hands like it, hurt, you can keep it down, no issue.
It's okay.
What is a deadlock? So deadlock is something when the operating system, the combination of the processes and the demands, when the operating system can't get fulfilled, the situation would occur such a way that you can't work good, you can't work smooth. The situation is like a dumb situation. That is called as a deadlock. So obviously the name suggests that deadlock means something the negative is happening into the operating system. Now how the operating system will handle those things, how the operating system will take care that deadlock should not occur. And in this particular model, we can see over here. Okay, now can you read the picture? I am saying to read, not just to see. So what kind of situation? What kind of situation you guys drive, you guys? Is it a something good situation? No, why it's not a good situation? Why it's not a good situation? No one can move. Why no one can move? Why no one can move? It is something locked. Okay, why? But thing is, again, why it is so? Okay, now let's take consider of this particular car. Why this car can't move? Why that car can't move? Okay, because the movement of this car is dependent upon this one or this one. This one again dependent upon this one. This likewise. So because of the dependency, so all those processes are in such a situation that they can't move. Same thing happen into the process operating system, there are n number of the processes which may dependent upon each other, and because of that they won't execute. You know the cycle of the process. What is the cycle of the process? Process get created, new, what we call, now PPT is one of the program I installed it. It is a program. Now I open a PPT. So what will happen? It will become into the active one. And that active one we call it as a process. So new it will become. Then it will go into the which state after new? Running state. We open a PPT, we play it. It's a running state. During that one it may require some resources. Maybe this particular PPT requires the microphone, this particular PPT may require some tables, anything may require some database. So it may go into again a waiting state. That resources would are available, again it will go into the running state. Once that PPT will get completed, I will close the PPT. What will happen? The process get terminated. This is the life cycle of the process, as like a life cycle of human. Birth, do something, death. Process also has the same life cycle, get created, exit. So every process has to get exited. And do you know the basic phenomena or basic rule of the exit? When the process get exited, terminated, can the process will get exited after new state? Can the process get exited after waiting state? So when the process would get exited? After running phase only. When the process will complete its execution, then only get process will completed. So this sort of basic phenomena or the basic or fundamental law of the process state. Process has to exit only after its execution state. If the process can't complete the execution state, process will be into the system only. And when the process will complete its execution, when its required resources are available, then only process can complete its execution. If the required resources won't be available, process can't complete the execution. We see in a movie, Bhatakti Atma. That type process will remain into the system. So, like it's a deadlock, right? We'll see that later on again. What is a deadlock? So like this one. So let's say there is only one train track and the two train would come. No one can move. That's a deadlock situation. So in operating system also, the processes get locked. Maybe they are waiting to each other to get completed. And that's why none of the process would complete its execution because they are waiting for the resources. And because of that one, process can't complete its execution. So process will get created, it will be into the waiting state only. It can't get CPU to complete its execution, so it can't exit. So that right portion won't get happen. Just recall that diagram. So we'll give an example, what is a deadlock. So basically what is the system? As I said, it's a number of processes and number of resources. The process has to demand the resources which are available to the operating system. Keep quiet, wait. So what does it mean? In this particular class, if there are 40 benches and someone can demand max 40 benches, what will happen if that particular person will demand 45 benches? Will his requirement get fulfilled? Never. Let's say there are two processes. This one process, he said, I want 20 benches. Okay, I will say, now I am a, let's say, a manager of this particular classroom. He demanded 20 benches. I have 40 benches. Should I allocate him? Yes, you can take it out. Now next person will come. He said, now how many benches left to me? Only 20. He said, I want 25 benches. What should be my decision? Should I allow to enter him? Yes or no? I can allow, no? Why? Why I can't deny him? We don't have right now 20 process. 25 process. Benches. But I know someone has taken that. He may deposit after its completion. Again I would have a 40 benches. I can allocate him. That lady would come and she said, I want 50 benches. In that case, what I know, ever in a future, I can't arrange her 50 benches. So being an operating system, I have to manage those things. I would allow only those processes, those demands, the resources which are the less than the number. So you have ever seen, just I will give an example. You have opened a PDF. Now you do the control P. You do the control P. So let's say only one printer is available. PPT, another, let's say it's a shared printer. Usually in offices we do have that one. People from different cabin, they can share that central printer. Okay, so someone is printing the PPT. Again I given to print the PDF. What will operating system do? Operating system thinks she has demanded the PDF to get printed out. She has demanded one printer is available, but that is been occupied by that person. So I will ask to wait. So you are seeing that thing, that printer has to be into the waiting condition. Once she will done with that her printing, my document will be into the queue. Now we take it the another example. I asked to get printed out, but the printer is not available. Do you go into the waiting state? No. Immediately operating system says to you, printer is not installed. So you have to demand, the processes has to demand the resources which are available. If I am demanding the printer which is not been available, what will happen? If operating system fools me, please wait, I will give you printer. What will happen? I will go into the waiting state. Do my requirement will get completed in the future? Never. What will happen? I will never get terminated because I never get the CPU to complete my task. So what does it mean? Operating system should allow to enter operating system allows only those processes to enter into the system which the resources are the less than the total number of the resources. If any person demanding the 50 benches, operating system won't allow. So every process requires the resources, use the resources, release the resource. So that resource could be available to the other person. Now we take one example. Again to read this particular picture. So let's say with my operating system, I have installed one printer and I have installed one CD drive. One printer, one instance. So let's say this is what the process A, PDF. It demands the CD drive. CD drive, you know the CD drive? You guys know the CD drive, pen drive, CD drive. So what we do in the CD drive? We write something content, we store that content into that optical device. Okay. Now let's say process A says I want to use the CD drive. I want to write the data into that PPT. I want to write the PPT into the CD drive. We will put some action like new or something, that software through which we are interested to write the data into the on a CD drive. Whether the operating system allows? Yes, no issue. Operating system allocates this available CD drive to the process A or the PPT. Fine. Now that particular process is into the writing state. Now another process, let's say PDF. It's a multi-programming operating system. We can open n number of the processes as per the capacity of your primary memory. So let's say another process will get active, PDF, and it demands the printer. The operating system has the one instance of the printer. Obvious, if that printer is available, no one is using the printer, operating system allocates this particular printer to the process. Now process A is using this one, process B is using this drive. Both are running parallel, no issue. Now meanwhile, during its run, process A again demands the printer. During the writing into the CD drive, process A demands the printer. Someone press the control P on the PPT. We can do, no? We can have the multiple axes. What will happen? Operating system does allow? It will allow. Why? Because process A demanded the one instance of the printer. Right now I don't have, but I can have later on. Okay? No issue, no? Now process B will complete its printing, get terminated. What will happen? Printer is available. Operating system will allocate a printer to the process A. Process A wants the two resources which are available. It will complete the it will acquire the two resources. It will complete the execution. Again, it will release. A good win-win situation. What could be the another scenario? Again, process A wants the CD drive. Operating system allocates it. Process B wants the printer. Operating system allocates it. Process A and B running parallel. They have acquired the corresponding resources. Process A demands the printer. Operating system says, please wait for some time. Fine. Oh, process A in a waiting state. Process B is using this one and it will say, I want CD drive. Operating system say, has a one instance of the CD drive. I can allocate to the process B. So what will happen now situation? Process A is holding this one, waiting for this one. Process B is holding this one, waiting for this one. What is this situation? What will happen? Can you imagine? Can process A complete its execution? No. Why? To complete his execution, it wants the two resources. Which one? CD-ROM and this one. When it will get that resource? When this particular process B release the resources. But when the process B will release the resource? When it will complete its execution. Again, when the process B will complete the execution? When it will get both the resources. But again, these resources it has, but these resources again it is not. So process A is waiting for process B to release this printer so it can complete its execution. Same scenario, process B is waiting for a process A to release the CD drive so that it will acquire both the resources. And this particular situation is similar to that road cross, that traffic rule. Everyone is waiting to everyone. No one can complete its execution. And this particular situation technically it is called as a deadlock. Have you got scenario? What is the deadlock? Can you relate this one with that crossing example? What is the win-win situation? If everyone gets this, everything. What is this worst case condition? So, when this deadlock occurs, to occur a deadlock into the operating system, there are 4 necessary conditions. One is a mutual exclusion. Can you tell me what is mutual exclusion? If one process has acquired the resource, we can't allocate it to the another resource. Because of the phenomena of this operating system, the deadlock occurs. If I am taking a lecture, I can't allow the database teacher to enter. It's a mutual exclusion. If I acquired for 1 hour, I should acquire it into the 1 hour. Like this. Process has acquired this CD-ROM. If that is using that resources, we can't allocate a process B during its execution. Mutual exclusion. The CD-ROM is exclusively allocated to the process A. And that's why we can't have that situation. PDF and PPT we can't print alongside. First PPT, then PDF or whatever the process scheduling it is being done. So because of that phenomena, process B has to wait unless process A release the CD-ROM. Hold and wait. This is not a hold and wait situation. Process A is holding this one, waiting for this situation. Process B is holding this one and waiting for this one. This is called as a hold and wait. Because of that, deadlock would occur. If the process is holding this resource and waiting for this one, suppose process B is only holding this one, is not waiting for this one. What will happen? There would have been deadlock? No. But here, in this particular scenario, hold and wait condition is there. Have you got what is the hold and wait? I am holding something and again waiting for another thing. No preemption policy. What is the no preemption policy? Once we allocate resources to that process, we can't take out. If I am taking a class, no one can take me out of the class. No preemption. Because of that policy, deadlock occurs. So process is holding the CD-ROM. I know CD-ROM required to the process B, but I can't take out the resources from the process A. operating system has some principles, no preemption. We can't take out the resources from the deadlock. And the circular way. What is the circular way? I am waiting for her, she is waiting for him, again he is waiting for her. All we three get blocked. That car crossing example. Car 1 is waiting for car 2 is waiting for car 3 is waiting for car 4 is again waiting for car 1. Circular way. Is this circular way? How? How circular way? What is circle? Circle complete होता है कहाँ? How? A to B, B to A. So whether this situation is signifies or proves all four conditions. I got those four conditions. Okay, I got them. So to occur a deadlock, all four conditions has to be there. If any of the condition won't be there, deadlock won't be there. Okay? But all four conditions are the necessary. Okay, for the deadlock one representation, some researchers had done, and they have done to, how they can define a deadlock situation. So they have given some graphical representation for the deadlock to occur. So how they can define a deadlock, how they can analyze a deadlock. So in study, so to represent this one, they have used the graph. You know what is the graph? What is graph? Set of edges and the vertices. Okay, we know the directed graph, undirected graph. Okay, what is a directed graph? You have that graph theory, something in this semester, or it was in previous? Okay. So, okay, got it. So to analyze if the system can have that deadlock or not, we are going to see how the scientists have defined. No issue. Okay, no issue. We'll go on discussing meanwhile. So to represent whether the deadlock किती वेळ जाते